So welcome back to our discussions of MySQL, this time the MySQL CreateTable statement. So the CreateTable syntax, so create table, and then optionally, if not exists, the table name, and then parentheses, close parentheses, and then followed by column definitions, more than one. So let's expand out the column definition. So they have the column definition, which is made up of the column name, then the data type, and then column constraints, rules about the column. Then we have more than one column definition, of course, and then followed by table constraints. So table constraints are data rules that apply across the contents of the table. So, as we said, rules that apply across the contents of the table. So here you'll see the definition of indexes or keys, unique keys, and primary keys. So I've organized these from general to specific. Indexes or keys are column or columns that you want to index. That is, you can specify, say, a last name as something you want to index, or a last name plus first name as something you want to index. And here, index or key are considered to be synonyms in MySQL. And what does that do for you? Suppose you write a customer contact list in your database, and it's used by customer support. It may be the portal for customer support. Customers call in, they don't know their customer ID or anything else. They know their first name and their last name. So you index on last name. You don't expect index to be unique, so you're expecting, let's say, Jones will come up with many hundreds of hits, but you've narrowed it down for customer support. Now, customer support can ask a few more questions on the summary screen, and then finally get down to the correct customer. Now, if you don't index last name, imagine that same system. What has to happen is the database will be searched from beginning to end for matches. And since the index isn't unique, the database will have to read all the rows in the table in order to get the list of last names that match. That's called a table scan. So if you have a column or a set of columns that you think will be searched on a lot, then you should index those. If you don't think that those indexes form something unique that is unique across the table, it's simply an index or a key. You don't want to index everything, though, because indexes are expensive to create, and that creation expense comes on the right of the table row because the index needs to be maintained. It speeds up the read, but it costs on the right. So there's a balance there on the creation of indexes. Now you should also notice this. The select statement, when we did the where clause, that's where the index would come into play. We as programmers didn't have to tell SQL that. It figures it out. So if you say select a certain number of columns from a table on a last name, if the last name is indexed, then SQL will automatically use that index. It's one of the nice things about it. So going on from index, more specifically, a unique key. So if you have a string or an identifier or a number in your database table that you think is going to be unique across the table, that is, there's no other row that has that value, then you can use a unique key. For example, Social Security number might be a unique key in your system. A student information system may be the student identifier. Right? A license plate number or license plate, driver's license number. Those all might be unique keys in a database that uniquely identify a person. Now, if you make a mistake here, what will happen is the data row will be rejected if you try to write a data row that has a column that violates that unique key. Like the index, the unique key can be made up of components, is segmented. So last name plus first name plus middle initial plus the last four digits of Social Security. You might say, for example, to define as a unique key in your database, and that would depend on your business rules and your business judgment. Stepping on from the unique key is the primary key, which has some characteristics with a unique key, but a little bit special. So many things can be identified as a unique key in a data table. So you can say social security number is a unique key. Maybe student identifier is a unique key if you have both in a table. Many things can be defined as unique keys. The primary key, however, can only be defined once for a table. It's indexed, but it also is a strong assertion about the structure of the table. Remember, the definition of SQL came from relational database management systems, which sprang from the mind of mathematicians. So, for a mathematician, this is an f of x problem, where the function is defined as give me the data row, and x in that function is the primary key. It really is central to the idea of a relational database, more so than the unique key. So it has to be unique. It's a constraint because it has to be unique across all the table rows. So social security number could be a primary key. That could also be a unique key. But social security number, say, is used as a primary key. You could have an integer or a number that used as a counter. That could be a primary key. But again, if you attempt to insert a data row that violates the primary key constraint, that row would be rejected because there's already a row in the data table that has that primary key. So that's a powerful notion. You may have millions of rows, and SQL will check to make sure that column or set of columns in that proposed row is unique and maintained unique, that it can't be updated and changed to be non-unique. One more thing about unique keys versus primary keys. Unique keys support the idea of null. Since null can't be said to be equal to each other, a unique key will tolerate a null, whereas a primary key can never be null. They all can be defined, by the way, as segments, that is, on a single column or a set of columns in order to define these keys. And always, SQL, when you're doing the select statement, will use the keys automatically. So in summary, indexes are unique keys used for fast data lookup. Primary key also used for fast data lookup. It is indexed, but it also is an assertion about the structure, the logical structure of the table. So in commercial databases, all data tables should be defined with the primary key. Foreign keys. Foreign keys put the relational in relational database, and very important to understand. It's a constraint placed on the rows of another or foreign table. So think of our example. We have order and we have order details. Order details is foreign keyed to orders. That's where the line comes. That's where, when we looked at the enterprise relational diagram, those lines are defined by those foreign keys, the one-to-many relationships. That is you can think of it as a fishing line that comes from the child table and it hooks on to another table, normally via the primary key of the foreign table. That's what ties those two records together. Think of, again, about order details. Order details has an order number. Order has an order number. That forms part of the foreign key that relates those two tables. And then that's repeated over and over again through the database table design. So you get these complex looking diagrams, but remember, it'll simplify in your mind if you think of those relationships as 2 by 2. This table has the relationship with this table. Now those tables may have other foreign key relationships that get built that form this complex machine, but understand it 2 by 2. All right, we're going to see examples of the creation of data tables next, and we're going to look at the classic models database that we've been using throughout our course in MySQL. Thank you.